Right, debugger works. All right. What is the problem? Two, command not found. What the hell is your problem? Oh. Right. Okay, so we are in a building situation right now. Okay, so what do we got? We got bugs to fix. Okay, so we have detecting change in type. Change in number of children for floating watches. Okay, so that's probably what we'll work on first. All right, so what that is we need to be able to detect the change in types. Okay, so we need this to work. so what's going on here? I think this is in our like spec file, right? So we have, so the issue here is that if I do this and I do like test struct, right? Oh, okay, so no, that'll pin it to a frame, right? Let me see. Public, right. Okay, and then if I do a floating one as test struct, then it'll be the same as well. So now if we step into multiple test, this should change to a test struct 2. It does. But it does not get the new members. Okay, so that's interesting. That's like another bug. Man, this is riddled with bugs. Or it's going to take us a long time. Right, this is the bug. Right. It's because frame 0, the meaning of frame 0 changes over time. Because it's relative to like where you started. So, so how do we want to do that? I mean, we can sort of invert the number, right? And say like, we could call it like -1. And then it would just subtract from the end. Do we know about the number of threads, number of frames we have? No, we'll never. It's not guaranteed that we'll actually know the number of frames that we have. Because it's sort of a heavy operation. It is theoretically a heavy operation to walk all the way back. So, the easiest thing for me to reason about is to not use a frame number to indicate depth, but instead use the function that it's in to indicate depth. The function name, rather. And so that actually seems the most intuitive. The problem that I have with that is, like, what if you have, like, the situation where you have, like, multiple... Bert, why is this channel for mature audiences? Have you been around me? I swear and curse all the time. Plus, I don't want to talk to kids. Kids are dumb. I'm just kidding. I'm sure kids are fine. In case, like, my future children ever watch this. Yeah. So I don't know. Let's just do it by name. Actually, so what happens to... Okay, so let me, so I need to, like, reset the state here. So let's go ahead and get rid of all these guys. And then if I do, like, restart. Okay. And let's continue. And right here, we have, let's do test struct. All right, so frame 0 right now is in multiple tests. And then we do test struct here. Okay. All right, so now if we finish here, what happens? No value, right? And that becomes, all right, so it looks like when these get added and they're pinned, they continue to stay at that level. So like, if I ran into nested 1 and stepped into that, I would have no value. So let me put a test struct in nested 1. Okay, so then here we do test. Okay. So that's that. Let's do looks like Discord went out. It's got technical difficulties. That's distracting. Excuse me for a second. All right. Okay. So I've got this test struct free right here. All right. So that's that. And then compile. Okay, good. Okay, so we need to get rid of these guys, reset the state. All right, so now let's continue on to here. Let's set a breakpoint here. And then we'll do a test struct here. This one's going to be frame1, test struct here, frame2. Why is... Oh, we're in the constructor of test struct 1. Oh, that's going to be even more confused. That's going to mess up my test. Oh my gosh. Something else to worry about. Somehow that got there. Oh, it's because, right, line numbers. Okay. So let's go ahead and get all that going. Okay, all right. Continue. Okay, so now let's why are we already in nested one? We should have stopped in multiple tests first. Okay, kill, restart, continue. All right, we're in multiple tests. Okay, so test struct. Frame0, test struct, frame1. Okay, these are of the two different types that we have here. Okay, and so now we will finish out of the frame. And it gets to no value. Okay, so here's one problem already, right? I mean, obviously it detected that it changed value here. Okay, so we have like so many issues to work out. So much like the watch window has a bunch of functionality as it is, but it's still like half broken. Like, once you get down to the specifics. So, and this is one example. It's like, we've got this issue where the child elements are not getting updated when the base element is changing. So, that's something we have to watch out for. Also, we have this issue of this frame identifier number doesn't actually mean anything. I'm gonna restart real quick. Okay, so and then continue. And somehow these are like the same values. Let's just get rid of these. Run restart. Okay. Now let's go into there and we'll do test struct. Okay, so there we are. And then we're going to finish here. Well, actually, no, hold on. We need to record this address number. Okay, so right now our stack address here is 54A6F. Right? Okay, so now if we did this here, if we did like P stack pointer, like SP, right? There, okay. Okay, so that's the address of the function. Right. Okay, that's not the address of the stack. Interesting. Okay, so here we are. And let's finish out. So we're back. We popped off some stacks, so we should be lower. We should be high. I guess we're higher on the stack now. Okay. Because it grows down, so we shrunk back up. I hope that makes sense. Okay, so and just to prove that, let's go forward like a couple things here. Whoa. What happened? I'm not sure what happened. Damn it. Gotta restart my thing. Okay. So here I am, right? Okay, my stack pointer is FDF30. Okay, so now if I like go here, for example, why didn't the stack pointer go up? Okay. If I run to here, it probably would go up. No. It's because we haven't made a new stack frame, I bet. Maybe. So it's not actually pointing to the end of the stack. It's just pointing to where the last stack frame ended. Or starts, probably. Right. I think that makes sense. So what about here? FDF30, FDFE, FDE E0. So that's, so that went down. All right, so if we go to our next breakpoint, which is here, what's our stack pointer now? FDE 0. Okay. So that really doesn't help because both frames are literally at the same stack pointer address. Start at the same address. So, even though we're like in two different functions. I mean, that makes sense because it would be governed by the size of the parent stack. I guess I was just assuming that all this stuff that was declared in this frame would sort of like just get pushed on to the stack. Like, and so like the more stuff you declared, the next frame would be like an even further lower address. But I haven't really had access to good debuggers, so I probably wouldn't know that. But now I do, and I'm starting to figure that out. So, unless there's something broken, that appears to be what's going on. So, if we go into next step. So we're in another function. We're in another layer deep now. So our stack pointer should be even lower, right? So we're at FDEC0 instead of FDE E0. And so that is the lower address. Okay, and then I assume if we kept going, we would keep going further down the address range. Okay. So that is good. Okay, so to really test this, what I need to do is I need to put like I need to put in like another nested function to like set off its stack pointer address. So, we'll do like void multiple nested here, and we're gonna do like a test struct 4 here. All right. And then we're going to do test struct for test struct. We're going to do something in here. There we go. And then we will we'll call it so multiple nested there, and then we will do, actually let's just call this other nested. Okay. And in here, we're going to do another test struct. And we're going to call this one test struct 5. Okay, so the sizes of those stacks should be really different, but I'm going to do something to exaggerate the size of the stack to make the change of the size of the stacks even greater. So I'm going to do like padding, right? 1024. There we go. All right, so that's that. So we're going to compile, build, okay, and then let's go ahead and get rid of all of these breakpoints. And let's go ahead and restart. And we want to stop here. And we want to stop here. Okay. So there we are, other nested. So we're going to do test struct. Okay. What does that even do? Oh, it never compiled. Oh my gosh. All right, let's restart. Okay, continue. Okay, so here we are, test struct here. And we're in other nested. We'll do that one. Okay, and then test struct here. We'll do that one. And that one. So we got 3 different types there. And our stack pointer is FDA90. So we should be at a different stack address the next time we stop, hopefully. So let's go to continue. And then we're here, now we're in nested 2. No value, no value. Okay, so that's pretty concerning. Okay, FDE 90. Yeah, okay, so we are at two different stack addresses, and it is evident that these nested, or these watched values are incorrect, because I was like hoping that these would at least update to the new values. But the thing is that when they are set to no value, they still exist at that location. So I think we always want to remove them if that happens. Like I'm pretty sure we always, like, obviously we want to keep them on this list, but we always want to release our handle to the GDB version of that variable object every time, like, it loses its value, right? Like, unless you're doing something like I don't know. Of course, then there's the issue of, like, where, like, you're, like, in some editors or, debuggers, it, like, vanishes right away. So, and we don't want the value to vanish. We at least want it to have, like, a cached version of its old value. And that's at least something that we get with this way. So, So what we want is, like, something that says that it's a stale value, right? Okay. Where is my watched expression? Is error hit recently? So what's actually happening in the, conversation with GDB, you know, that's precipitating this? Let's see here. Okay, so here I am replacing the cached value here with no cached value. Okay. So I think what we want to say here is, instead of doing this, I think what we want to do is that we're only going to free that if we do have a new value. Okay? So we're going to replace that. Okay? And instead of replacing it with the string no value, we are going to just keep the value as it is. And we are also going to set some sort of flag on it that's like stale equals true. All right. And then so that should make it so that we keep our value in there. Why did this compile fine? Right, stale. It did not compile fine. Alright, so we need to... I don't know. There's a lot of noise there, and it bothers me. Alright. It's full stale. And let's also go over to the HUMBUG GUI. Expression. Yeah, here we go. Okay, so that's that. So what does that look like? So let's remove all of these guys. Restart. Continue. Test struct. Other nested. Right. And so then if we leave that frame, it says that it's stale now. Okay, so that's what we want. So another thing, though, is that we want I think we want to cache the name of this expression. Right? Or, I mean, not the name of the expression, but the name of the frame. I don't know. Let's that's a little bit ambitious. Let's hold off on that. We still don't have like basic things working, so here we have it so that it's not getting rid of test struct 4 when it's gone. So we need okay, so if we don't get this the first time and we specify thread and frame, then we should just never try to make that again in the future. Right? Because there's no point. That only makes sense for floating variables. So that's what we need to probably do. So it'll never check the cache. Well, I don't know. All right, so I want to quit. I'm done. I just want to play Zelda. How long have I been streaming? I've only been streaming an hour. God damn it. All right, well, let's see here. And by when I say I just want to play Zelda, I mean I have like no brain power left in this whole week. I've been trying to troubleshoot this stupid e-poll bug like since yesterday. It's so dumb. All right, so let's think this through. So the real problem is that it's not creating new entries. Okay, yeah, okay. So the real problem is that it won't create a new entry if I try to add one, because this thread 1 frame 0 entry already exists. So what I need to do is sort of skip over all stale entries. That's what I need to do. It's pretty basic. Okay. So, so what, like, that's in like evaluate expression, right? So here's the thing. As far as the backend is concerned, there's no difference between this stale entry and like a new one. So like when you literally add one, you sort of have to like say this is new. Right? So we're gonna add that as a thing. So here's the evaluate expression. And then we want some sort of like this idea of like new. Or like not new. Or use existing. Right? That makes sense. Use existing. Alright, so we got use existing, and then like after that, we're going to say, man, why is this all like messed up? Gosh damn it. I have, what? For coder? I have to put a blank line there for you to like, don't get it, don't understand. What is the deal? You have to admit, that is pretty bizarre behavior. Like, of all the ways that you could have, I don't know, it's probably a bug. So anyway, watches LC, use existing, we're going to set that to true. Okay, so there we go. Hold on. So it's not going to be that simple. Because evaluate expression is only going to go through one time. I don't know. Okay, I'm done. This is my brain power is embarrassingly lacking today. So we are going to just comment out these guys, make sure we compile. And we are going to call it a day, I think. Or maybe I'll pick like an easier problem. Something that's a bit more rote. No, I just need to, I mean, that's the next thing I need to do. Thanks for watching. Sorry it's such a short stream. I'm probably gonna try to stream tomorrow since today was such a short stream. So we'll call this part 1. So, anyway, I don't know if anybody's watching, but take care, and I'll see you all tomorrow, hopefully. So, all right.